I mean, think about it. The brain's fighting to find the horizon, right? It's fighting to get the eyes on the horizon. It's trying to get the vestibular system, the ears on the horizon. And so if you've got two legs that are different lengths and you're trying to find the center of pressure on there, there's going to be some postural drifting. And I'm sorry, man, but if you've got this distorted center of pressure and you're spending some of your time and resources recalculating center of pressure and equilibrium and balance, I'm pretty sure you're not using those resources for performance of that client, and so I still think asymmetry does matter. That's taxing the resources of that system to some degree. Sure, it might be small, but if you didn't have to do that, and if Usain didn't have to do that, it's quite possible he could run faster. There you have it, folks. There's a little tickler into the rest of the podcast. We'll keep you on the edge of your seat there. We've got some great stuff lined up for today. We talk a lot about endurance and fatigue and how your injuries may be brought on as you fatigue and ways to look into finding problems. And we've got a little clinical pearl and gem and a little fact-finding mission for you at the end. Maybe help you resolve some issues for you or your clients around big toe pain, hallux limitus, hallux rigidus. Got a little something you can try. So anyways, great pod lined up. Glad to have you guys. We know you're busy. Put on your favorite ear cans. Go for a run. And as we move into Thanksgiving here in America, we are grateful for all you guys here at the Gait Guys podcast, locally and abroad. We appreciate you. And we'll allow you guys to reciprocate in the new year if you'd like to with PayPal or Patreon donation to allow us to continue some of our projects. But that for another time. Let's head into the pod. All right, so we've got our neuroscience piece, since we've got a lot of new listeners all the time, and just a reminder, this is part of our show. It may not seem gait related, but when I try and tie it into this neuroscience stuff into where research is going and what we see coming down the pipeline for people who are in the gait community and looking at people's gait, which should be all of you if you're actually training and working with clients, but where things are going to be going, because technology is moving quickly, and if we don't know what's going on, we're not following it, we may not be able to follow it as well or as quickly as we probably should. But I think when you're engaged with this kind of stuff, you probably are thinking along the lines of some of these very kind of creative researchers, and it may actually spark some genius in yourself. So we bring these things on not only because they're interesting, but we think they've got a really significant part in play with our clients, particularly from the neuroscience and neurologic side, which is near and dear to Ivo's heart, and certainly slowly becoming more near and dear to mine. So let's just jump right into this stuff. What'd you think of these pieces? We can start with that first one if you want, about the skin cells. What'd you think about this? I certainly have some thoughts, but
it reminded me of, in the article, first of all, what they're talking about is rather than using stem cells, researchers are using skin cells and turning these into motor neurons. And it has to do with RNA, the whole transcription factors. And they've got special names in here for everything, and they did specific skin cells and basically coerced them into becoming motor neurons, and they didn't use stem cells. So from what I took from the article is they're talking a lot about ethical concerns with stem cell and that kind of stuff. And that certainly can be a concern, but when you're looking at like embryonic stem cell, it's taken from an umbilical cord so it's not, it's not like you're taking cells from a living being or something like that. It's the umbilical cord, the portion that's been thrown away in the biohazard. And then it also reminded me of another paper, and I believe we talked about it on the pod a while ago when we were talking about stem cell, and this could be several months ago, but they've perfected this procedure for exactly the same reason, to be able to take these cells and convert them. Except they didn't do it. Well, they did it with skin cells, and they didn't do motor neurons. They converted them into any kind of cell they wanted, but they basically reverted cells from human foreskins. So they basically took, kids' foreskins that were circumcised, and that part, of course, is being thrown away, and then they took the cells from there. So it's a similar science behind this. The exciting thing, of course, about the paper here is if we can convert these directly into motor neurons, gosh, diseases like ALS and multiple sclerosis, possibly muscular dystrophy, all those sorts of things could really show some promise and some hope for rehabilitation from that. So it was interesting.
Yeah, the biggies that they were talking about was amyotrophic lateral sclerosis, or ALS, as some people know. I know the whole ice bucket challenge thing, and spinal muscular atrophies, those types of disorders. But anything that's and those are more more spine related, but motor neurons are motor neurons. As you said, that this kind of bypasses the ethical issues that are brought up using stem cells, which is always good because that debate tends to mute scientific progress. But for reasons that people may have, that's their their say on it. But these guys were out of the University of Washington School of Medicine in St. Louis, and this was published in Stem Cell Journal. We'll put that in the show notes as well as this article so that you have it. But I thought it was just interesting how they, as science, we've talked about CRISPR in the past, and this is kind of similar in respects that it's working off the RNA molecules, but it's really interesting stuff. It's amazing how quickly that science is moving here. It seems literally every podcast we do, we've got another leap in, brilliance in terms of utilizing science and engineering to manipulate the system to, get us closer and closer to not only wearable technology, but implantable technology, and now restorative or regenerative technology. And that's where this stuff is going. It's certainly going to help us mitigate the disease processes. And I think that they alluded to that in this article, that, we certainly want to use these things to help people get healthy. But, maybe the step before it, as they suggested, was to look at this and maybe take these skin cells of people who have these known diseases and see if they can replicate the disease through the skin cell motor neuron replication process. And then, as always, if you understand the disease, you understand the fix a little bit better. So I just thought it was interesting. It's neat that they were able to turn these spinal motor neurons around within 30 days, utilizing the transcription factors. So very cool stuff. And, it's one of those things, if you're taking good care of yourself right now, we're going to have the very likelihood that if you do come down with something that is devastating, and in this next article, we'll talk about, tissue damage. If you can keep yourself healthy long enough, you're going to be able to benefit from some of these things. If the FDA can turn these things around quick enough, if you're not taking care of yourself in your 60s, 70s, or maybe even 80s, you may not benefit from some of these things, including implantable technology. But if you're in your 20s, 30s, and 40s, even joint replacements are moving quickly. So this stuff is definitely moving ahead quickly enough that a lot of us are going to be able to benefit from this in some respects. So at least from the regenerative medicine standpoint. So what did you think of the immune cells? Using immune cells release red flag to activate muscle stem cells in response to damage. And this one I'll kind of give you a background on it because some of you may not understand some of this stuff, and I certainly didn't, so I had to look it up. But muscle stem cells nestle along our muscle fibers and quietly await the biological red flag that will tell them to leap into action and form new muscle fibers. But they really didn't understand how this occurred. And as one of the researchers said, that it might make intuitive sense that the same cells that are sent into a site of injury to clean up the mess should also be the ones carrying the tools and signals needed to rebuild what was destroyed. But they found out that it's not really the case. These are brought in by the macrophages to signal the launch and rebuilding process of these muscle stem cells. And so this was based off of some of the studies that they found that were similar in fat metabolism and obesity. And it's now been shown to produce muscle stem cells in action via an important signaling pathway called Notch. And it's not important, I guess, that we understand that process of Notch and this molecule called ADAMTS1, which is implicated in the fat metabolism. But I think it was just very interesting that we're understanding now how muscles also have this stem cell effect to, obviously after a workout, if you get sore and you damage some tissue, or if there is just frank trauma or post-operatively, these muscle stem cells will kick into action. What was neat in the study is that they found that they were doing these in mice in the murine population, of course, and they were obviously triggering this over and over again just to study it, but they found that there was a depletion effect in these mice in their supply of muscle stem cells, so that over time they eventually became less able than normal mice to repair the muscle damage. So there's obviously not a endless supply of this stuff. But what'd you think of all this?
I wasn't really surprised because the immune system is involved with so many aspects of the rehabilitation process, more so than we realize. The whole chronic inflammation leading to disease model, that's been coming forth over the last several years. The coolest part about it was this chemical or this molecule, the atom TS1, is basically something that the macrophages, which are in the area when you have damage, the macrophages, we think of, white blood cells, monocytes, things like that are in the area, bites off a little piece of the protein that's on the surface of the muscle stem cell, and basically that tells the cell to start multiplying. So this other one called Notch1 is basically what's keeping the muscle fiber cell in check. So the little macrophage or the molecule portion of the macrophage bites that off, and then that allows it to degenerate. So it's only a matter of time before we really start to unravel more and more of what's actually going on. And who knows, maybe one day there'll be like a little pill that you can take, or an app that you can hit, or something like that, that's basically going to cause atom TS1 to be released. And that's going to, signal muscle repair. And then, of course, there'll be some time acceleration process, science fiction like, so we'll be able to heal, before our very eyes. But it was pretty cool. And it just goes to show, it's nice to see science moving forward, as it usually does, but it's nice to see it making the news and doing some really cool stuff for us.
Yeah, and to make this more personal, I mean, a lot of you who are listening to this are either treating people who are injured or are athletes yourselves, and maybe you've ruptured. I put up a video last week or 2 weeks ago of a CrossFit athlete of mine who had ruptured a medial calf, and there was all kinds of although in the video I saw him the same day, the next day it was all black and blue and swelling down into the leg. Obviously, there was a partial rupture of the medial gastroc, and so this process is what happens. This is what turns on. At least we know it does in mice, so we know that there's a very similar thing happening in humans because the physiology is not that different. So these things happen in our injured clients, these processes. And so if you understand, like Ivo and I, we just like to understand the process down to the cellular and neurologic levels, because that's actually what's happening to your client. And some clients want to know these things, and it's kind of neat to have a conversation. I mean, I know your visits are like mine. They're anywhere from 45 minutes to an hour, depending on, what you're dealing with and how many issues you're dealing with the client. And, you got to talk about something. You might as well start educating your patient. I'm like you. I tell them why we do this exercise and what we found and how this correlates to what they're doing in their activity and why this tissue is strained. But they're in there several times over, a month for care, or over a month or two. I treat my clients about once every 2 weeks, but they want to be educated. And I've found that the more I educate them, the more involved they become in the process. There are very few clients that come in and just say, it's my knee, and they just lay down and they zonk out into, their own little world. Most clients want to know what's going on. And the more the more educated you are, the better you will, gain that trust of your clients. And so, if you learn, client learns, it's a win-win for everybody. But these neuroscience pieces, this is a perfect example. You rupture a hamstring, you strain a glute, you whatever. I mean, this is the process that goes on. Muscle stem cell kicks in, and we think that this repair process is very similar to what occurs in mice. So we will find out as this translates over into some probably human physiology studies, but you got to start somewhere.
There was a follow-up. There's a guy named Rando. He's doing some work over at Stanford, and it's related to this in that, this is great that it causes regeneration, but how do you support that process? And his research is pretty much about that, and a lot of it has to do with, the thing that he is into is, how do you encourage the muscle stem cells to replace the missing muscle? And they see this in people that have these massive gaping injuries and things like that. So basically creating a familiar environment for those cells to be in, and they create basically a biological scaffolding in the area for everything to build upon. So doing that, encouraging other cells to migrate to the area, and then supporting that with exercise. As we know, exercise, particularly aerobic exercise, is going to have a number of different effects physiologically on muscles. It's going to increase capillary density. It's going to increase mitochondrial density. It's going to increase, glycogen content, myoglobin, et cetera, et cetera. So by providing a good environment for that to occur, you're going to encourage that as well. And, I know you do a lot of that in the office. We do that as well, as far as, with different modalities, nutrition, laser, things like that, just basically everything you can possibly do to try to expedite the healing process as much as we can.
Yeah, and it's good that you brought up the nutrition standpoint, because there are those clients that, if you're putting crap in your body and you're very inflamed, and you've got these, a lot of sugars, a lot of gluten, a lot of things that are actually taxing some of the healing capabilities of the gut lining, which is your first initial line of defense to the immune system and the healing response. If you're tapping that system out, it's going to be a little bit slanted towards trying to cope with those types of things rather than the injury down at the ankle or at the calf or whatever. So, the healthier your gut is and the healthier you are with the better food, and, you're getting proper nutrients, and we all probably have some nutritional deficiencies that may actually, inhibit the healing process. It might be nice to maximize those things. So having these dialogues with clients, this is why I need you on, a diet. This is why I need you to have a certain amount of protein. This is why I need to have you, taking things that keep the inflammation down so that we can actually cope with this injury. Because a lot of clients that kind of just, sadly, I think it's human nature for most of us to try and get the most out of something without putting the least amount of effort in. I think it's just the economical way a lot of humans work, and unfortunately the way a lot of patients work. Did you do your homework? Well, most days I did, and I'm like, well, so certain days you just didn't seem to care about this injury. Well, no, it's not the case, but you get tied up in life, and you got kids, you've got a job, you've got and you can make up every excuse in the world. There's no reason why you shouldn't, but let's be realistic here. People often don't do as much self-care as they should. The highly motivated ones are the professional athletes, and the ones that maybe have been in pain a lot longer and are finally making that commitment. But I'm rambling on here, but it's more than just a local do your homework and things should be good. Sometimes there's multi-layers to this, and some people come in and they're pretty sick, as I know you see, and you do a lot of more nutritional stuff than I do in acupuncture, and I don't have cold laser or any modalities in my office. I generally just try and take care of the mechanical things. Arguably I should add those things. I know that I should add those things, but I just don't feel like I'm a jack of a lot of trades. I only know a couple things really well, and I have a support system outside of my office with some people here in Chicago that can help me with that. I know your scenario is a little bit different. You're kind of isolated from a lot of people, so you've had to become a genius in a lot of things. So, I'd say that your perspective is probably way more complete than mine, and that's not a pat on the back. I think it's just accurate because I've seen how you practice, and a little bit of jealousy there, but I understand that if I, push the limit there, I could probably do more on my own. But back to the topic at hand, your client has to be willing to make an effort. And if they're not doing the homework as much, call them out on it. I always say I can't be more invested in your injury than you are. So all I'm asking you to do is do, several times a day, 2 minutes of work just to try and make this thing progress in the direction that we want. And so some clients need called out, and quite often they usually take the slap well and they start to step up, and that's what they're there for. So to get better.
And just piggybacking on that, when you're talking about nutrition, it's not always a deficiency. Sometimes it's reactivity. So, you mentioned gluten, dairy, which are common, but some people just react to foods differently, and that creates a low level of inflammation, which is going to kind of percolate along and just inhibit the whole healing process. And we spend, a fair amount of time trying to dissect those sensitivities or chemical reactivities as opposed to actual allergic reactions and those sorts of things out. I'm in a little more of a rural area. My population of patients is similar, though. I think that I treat a lot of athletes. My athletes might be a little older than yours as far as that, but we treat a lot of people that are very interested in doing, what we do. Like the psychotherapist at our office, Tom, runs 4 100-milers per year to raise money for a charity that he supports. And it's pretty cool. He just finished, his third 100 of the year, just like a week ago. And it's just, absolutely amazing and astonishing. But, Tom is a little bit older than I am. So he's almost 60 and he does 4 of these a year, it's that level. And when people get to that level, they're that much more committed to doing what it takes. And, I don't know if it's maturity, is it just drive, whatever it is. But I think when people get to, a lot of times, and I'm sure it's this way in your office as well, by the time they get to you, they've kind of been everywhere. They've kind of done everything. And they're ready to do whatever it's going to take. It's like, all right, I got to stand on my head and wrap cabbage around my nose, and do this. It's like, all right, if that's what it's going to take, then that's what I'm going to do, because I want to get better. And I'm just kidding about the cabbage thing. But the point is you need to do these exercises 3 to 5 times a day. They're doing them.
Mm-hmm. Yeah. I agree. We do have that similar practice in that people, usually we are, for a lot of people anyways, we're at the end of the road for a lot of folks. Their doctor has said, look, we've exhausted here. You need to go over and see these guys. Because they're a little bit more focused. And it's quite nice because a lot of these other doctors, they clean up a lot of the other stuff. And so we get to kind of just step in and mop up what's left over. And quite frequently, it's the easy stuff that we're real good at. It's easy for us just because we specialize in some of these things. But, it also it really develops some good relationships. You send some patients back to them for some of the lighter stuff that you may not have time for because my schedules, like yours, is pretty full. And when you're several weeks out in terms of scheduling clients, clients want to progress. So look, go and see Dr. Bob over here. He's going to take care of a couple things. Come back here, in 2 weeks, and I'll clean up the rest of the mechanical things. And it develops a relationship and a team effort. It's always good. Sets up your referral bases nicely. A little different for you being a little more rural, but you've got a good team within your office, so it works real well for you.
Yeah, we're very fortunate, and our scope of practice here is fairly broad as far as, the things we're able to do. So, it just makes it nice, and it's more convenient because I don't have to wait on a script or whatever. We have a lot of the modalities in the office available to us. But anyway, moving along to more gait-related things, you stuck this article in.
Let's go into the endurance stuff because that seemed to have got, we're into early October here. So by the time you hear this, we'll be a couple weeks out from there. But Ivan and I put up a lot of stuff, at least 3 in a row today or this week, on endurance and fatigue in athletes and comparing novice athletes to competitive or high-level athletes and looking at the fatigability and endurance issue and the incidence of injuries and the onset of injuries as fatigue continues. And as I commented, and then you took some interest, and I think we bounced some ideas around here that maybe some people haven't thought about, that a lot of injuries, we talk about skill, endurance, and strength. Yeah, we're reteaching skills. I mean, if you're doing a good job in your office, you're probably teaching clients what they're doing wrong and teaching them how to do some things right, whether it's loading, it's postural, it's, corrective work, or it's how they are lifting in the gym wrong and making some corrective and adaptive changes there. But a lot of times, in our second part of our mnemonic, skill, endurance, strength, endurance. So when we say, move well and then move often doesn't mean just go through the motions. It means go through the motions under a low load so that you can continue to build some degree of, baseline on this in terms of endurance from an aerobic standpoint. And then once they're able to move well, you up the skill and you move well again and you add a little bit of strength to that. And you just keep, as I say, rinse and repeat, skill, endurance, strength, up the skill, add endurance on that skill, add more strength, next level skill. I use the analogy like, okay, your problem right now is that you can't even find your glute in a bridge position. So you're kind of like in, preschool here. We need to teach you just how to find your glute in a bridge. And quite often, with what the term a lot of people are using now is gluteal amnesia, they just can't even find proper hip extension. They're using, lumbar extension. They're cranking into the hamstrings or using the quads too much. So sometimes you just have to teach the skill. A lot of times we go to strength too often. Let's get you squatting. Let's get you on the leg press machine. Let's get you doing lunges. Well, that's all fine and dandy, but if you haven't corrected the pattern, and this is one of my big beefs with a lot of things that are going on out in the world, is that clients come in and they're super strong in super crappy patterns. They've got great compensations with great endurance and strength on them, but they're coming in because they have pain, because they've overloaded the joint, and the muscles in that area improperly because of a compensation, because they're not into a correct primary pattern. They're not even using the lower abs and the glutes in a neutral pelvic position to get them to load correctly in a Romanian deadlift or in a squat or in whatever, you name it. So so we went on this little diatribe on our soapbox on skill, endurance, and strength, and the one study looked at novice runners showing greater changes in kinematics with fatigue compared to the competitive runners. We'll have that in the show notes, but it's on our Facebook page and social media, Twitter, etc. That was from Sports Biomechanics 2017. So we're not talking out of our buttholes here in terms of just spouting off things that we think we know. There's a bunch of studies out there that are correlating this stuff and finding out that there are some problems. And, I treat a lot of high school runners, particularly girls. And these girls hit freshman, junior year, and they go through a little bit of a growth spurt. And they've got these long, gangly legs that are, their nervous system hasn't really made some significant adaptations to coordinated and good coordinated locomotor skills in running. So you see the knees coming in, they're pronating, and their posture's horrible. And they come in and they've got whatever, medial ankle pain from the tib posterior. They've got valgus knee loading because their pelvises are getting a little bit wider and they can't get to their glutes. So they've got a very, a lot of knee flexion loading instead of creating enough stiffness in the glute in order to stay in a relative hip extension or controlled amount of hip flexion. So, we went on a couple little rants here this week. And then you put up something really interesting today that I completely overlooked, but I do in my office from time to time. So, what do you think about this stuff, and how do you approach it, and how do you get around that, the thing that you talked about today? Because I thought it was kind of interesting.
Well, first of all, when we think about the whole thing, skill, endurance, strength is so important just from a nervous system and a axonal fiber diameter and conduction velocity and all that. And that's why we're always talking about that. Pretty much most of the stuff we talk about here, we've got a reason. It's not just because it's our way and that's the way it is. It's like, this is physiology. We try to make most of our stuff, outcomes and research based. When you put the stuff up earlier in the week, talking about novice runners and stuff, it reminded me of a study. I don't know if you remember this, but used to do a lot of work with an orthotic company a number of years ago, not the one we were involved with together, but another one. And anyway, we did a research study for them. And basically what we did is we looked at power output in cyclists with and without orthotics. And what we were doing is, do orthotics really make a difference? And our parameters for measurement were 1, heart rate, and 2, basically power output. And with and without orthotics, of course, experienced versus inexperienced. We had a cohort of about 100. It wasn't an enormous study. And but the point was, the people that benefited most from the orthotic devices were the people that were the most experienced. And the people that benefited the least were the ones who were least experienced. And that folds into what you were talking about, because when you're a novice, you're not very mechanically efficient. It's just like skiing. When I was learning how to ski, I was awful, and I'm okay now. I'm not as good as my kid, who runs on the ski team and all that stuff. But the point is, I was very efficient, and I would go out for a few hours and I would be exhausted because I just didn't have that efficiency. I didn't have the motor patterns. I didn't have, the muscular endurance, that kind of stuff. And then as you become better and more efficient at it, and this is with any sport, it could be running, cycling, whatever, you just become better at it. And your body becomes more efficient. You hopefully have adapted decent patterns to be able to accomplish what it is that you want to accomplish. And when you're talking about this, some people, they're driven, and I admit I'm one of those people. I have a tendency to overtrain. The hardest thing for me to do is take days off and stuff like that. But I've really been forcing myself to do that because I just see that I'm just kind of running my body down. I've already worn out one hip. I'm working on the other one now. Things like that. But it really kind of spoke to me. So you mentioned you had 2 different things out, and go back and check out our posts. Go to TheGaitGuys.com and look at the stuff on endurance. But I just put something up. Like, I see a lot of people just like you do. The cyclist that comes in and says, "Doc, I get knee pain." It's like, all right, when are you getting it? Oh, I get it at about mile 60. And it's like, all right, so if he comes in my office in the morning and he hasn't already ridden, I'm not even going to be able to become close to reproducing what's going on with him. And the whole thing, and I think you'll agree with me, is if you can reproduce what's going on with the patient. You can reproduce that pain. You can usually fix it, or you can figure out a workaround. I mean, would you agree?
Oh, totally. Yeah.
Yeah. So what I'll do for those people, it's like, all right, we've got trainers, we've got treadmills, we've got all the toys in the office, but it's like, go out. I want you to pre-ride like 50 miles prior to coming to my office. And then when you get to the office, I'm going to stick you on the trainer. And you're going to ride your last 10 to 15 here while I can watch you periodically walking in and out of rooms, treating patients and things like that. And I want to see you when you crumple. I want to see you when you start to fail and that motor pattern that, you've been able to compensate for starts to break down. And I do that with runners. I do it with golfers. I do it with all of those people because it's sort of time dependent. Not everybody, a lot of people are good when they first wake up. And they get worse as time goes on, as muscular endurance wears down, as the pattern becomes, more prevalent throughout the day. And the gist of what I wrote, and I just wrote I put a couple references in there to looking at endurance-based stuff. Like, you do a cardiac stress test. Why? Because you want to see how the heart behaves under load. And we do the same things. And sometimes it's like, I've got a weightlifter, and it's after, he's doing squats. We'll have him doing a bunch of squats in the office before you evaluate him. He might pull off the first 10 perfectly, and then number 11 is where the system starts to break down. So it's the whole concept of what you and I like to call, pre-fatigue. It's like, let's start to wear them down a little bit and see where they're at. And I always tell my patients, it's like, when they're here, oh, doc, you're doing this, or you found this wrong, or whatever. It's like, look, I'm not here to tell you how good you are. I'm here to exploit your weaknesses because that's what you're paying me for. You want to be your best. So my job is to point out the flaws and then help you to work with that. And a lot of my patients, just like yours, are athletes, and they understand that, and they get it, and that's what they want. But it was just that whole concept of that. And then somebody on social media had written in that really, wasn't very practical. And I had to say, I really disagreed. You may not have all that stuff at your disposal, in your office, but you can certainly pre-fatigue people. Have them walk up and down the stairs. You can have them ride their bike to and from your place. I mean, there's a lot of other things you can do if you don't have the stuff in office. To be able to do that. Now, maybe, if it's during a track and field event and it's only during, a certain, after running the 400s or something, it might be a little more difficult, but you can still semi-approximate that. And, you may not have a treadmill in your office, but I'm sure you got a hallway. You may not have a great bike or something like that, but you can have a trainer, that you can stick people on. Mirrors are not that expensive. And just things like that, and then helping people to recognize that. So anyway, that was just the point of it. And your article for me, the two of them, really inspiration. I read through the second one. I was like, oh my gosh, we got to talk about this, because this falls right in with fatigue. So.
Yeah, I mean, it's, we always say skill first, skill, then endurance, then strength. Well, skill is kind of coordination. And what happens when you fatigue? You're going to lose some coordination. You're losing the ability to control the movement pattern, whether it's a runner. Let's just take a pitcher, for example, since we're, entering into the World Series here, that, or postseason, if you will, that, what happens to a pitcher in the seventh inning? They start getting tired. They start missing the strike zone. Their velocity starts coming down. Their ability to perform starts to decrease. Those shoulder muscles, the core, it's had enough. The system can't seem to dial in the efficiency and the specificity of the initial skill or movement pattern. And so as you fatigue, the coordination drops, and then eventually your strength starts to drop, and whether that's power, force output, or what have you. And in a runner, the same thing is going to happen. And so don't think that this doesn't happen. And along the topic that you had just said, before I step back again, is that it's not hard to tell your patient to show up 30 to 45 minutes early for their appointment and just go out for a run. And as soon as you get back in, the staff will page me, and I come and grab you, and I put you on the table, and I start assessing and looking at muscle patterns, movement patterns, looking for weaknesses. I mean, it's not as if they have to walk through the door and lay on your table. I mean, they're not going to fully recover in 10 minutes. So, but oftentimes I can get them into the table and lie them down. I said, look, we'll talk about your history in a moment. Let's just see if the pattern that we are suspicious of, or we were finding last time, shows up after the run. So it's not all that difficult to do. And like you said, put them on a bike, push their anaerobic capacity, if you will, on an anodyne bike, an air bike, and see what happens when you start taxing the system from that perspective. There's a lot of ways of doing it. A lot of patients come in the morning, and like you said, they're not fatigued, they're fully recovered, or they're coming in after a long day, and maybe they haven't eaten well, and maybe the things do express themselves a little easier, but when you see them in the mornings, things don't. I mean, this is where it becomes a practice, but it's really a lot of these things. I have patients, and we've talked about this. Patients are not going to, you give them some homework and they come back in 2 weeks and they say, oh, I'm so much stronger on my homework. And you and I both know, no, you're not stronger in 2 weeks, but you are more coordinated. But to you, it feels stronger because it's a cleaner, more coordinated pattern, but you're not stronger. You may be a little bit, but you're more likely have moved well and moved often and maybe start pushing a little bit of more, plastic type myelinated patterns that are a little bit more efficient. And so, as we like to say, it takes 10 to 12 weeks to own this thing. That's because it does take time to actually create the endurance and the strength changes. So, do you have a comment on that?
Nope. I think that you're right on there.
Yeah. And so a lot of clients, I've had visits where you have a patient lie down, you do your exam, and you have them do some single leg bridges in the supine position, and they're so weak, and they're all over the table. You do some work on them, you go out in the rehab room, you go through some patterns, maybe not that pattern, you do some other things, you have them come back in at the end of the session, I want you to show me your homework, and they show you the homework. This is within 30 minutes, 45 minutes. And they're like, oh, I'm so much stronger. I said, no, you're not stronger. You didn't get stronger in 45 minutes, but the pattern is more familiar to you. It means we're on the right path. And, a lot of clients, that's like, how did I get stronger? We just spent the last 45 minutes fatiguing that pattern. And I said, no, we were just challenging you. I know it felt fatiguing because you're not coordinated, but we didn't push you that hard to fatigue you. But what we did is force you into the corrective pattern, which you should have had all along. So it creates a lot of buy-in for folks. So don't be afraid to, and I do this a lot, let's go over your homework, and then you go through the treatment, and then you say, let's go over your homework at the end again, or maybe you tweak it, and they're like, that is so much better. Good, you're more coordinated. It's a little cleaner pattern. We've got things dialed in. And so it creates buy-in for clients, and I do that a lot. Patients don't tend to remember the homework if you show it to them just once. So I make sure we go over at least 2 or 3 times, and I make the homework part of the session that day so that they know that there's some good carryover, because there's nothing more frustrated than a client that goes home with the homework, comes back 2 weeks later, show me your homework, and it's not what you're looking for. But, it's part of the learning process. I used to have to, as I'm sure you did, you have to draw out the homework and stick diagrams, but, with the advent of the smartphone, everybody's got their own camera. You just film their homework, them doing their homework on their phone, so it's quite nice.
Exactly. We do that all the time. And then our backup is, oh, well, I don't have my phone. It's like, okay, I've got my iPad. I'll just send you the file. There's no you're going to forget it or, whatever. And that's a lot of times how you can weed out those people that are super serious versus the people that are kind of looking for the magic bullet. And, sometimes there is a magic bullet, but a lot of times in my experience, there's not.
So something that we talk about a lot, leg length discrepancies and posture, right?
Yep.
And did you want to go down this rabbit hole, or do you want to go down the foot intrinsic stuff that you had put up earlier in the week?
No, I think we can probably have time to talk about both, but right. It was interesting, as far as this is out of British Medical Council Musculoskeletal Disorders 2017. Does structural leg length discrepancy affect postural control? And it was a prelim study where they looked at 38 people. 19 of them had structural leg length discrepancies, 19 did not. And then they did some statistical analysis on these individuals and then looked at asymmetries in weight distribution and centers of pressure. So I'll let you go ahead, and then I'll just kind of jump in after you're done there, because you're the one that had put this up there, and then we can talk about that.
Yeah, well, just before I get started, there's a lot of emails that we get, a lot of messages and a lot of comments on social media, and certain names tend to come up and certain names are positive, and some people just like to troll and stir the pot, and I could care less about that. If it's a good debate, I don't care if you're trolling us or not. If it's a good debate, I'm ready to jump in. So try not to take these things too personally, but there are some people that say, these structural and functional leg links. I don't believe that these things happen. But, when, for example, the Usain Bolt article comes along, he's got a short leg and he's got a scoliosis, they're certainly happy to jump on that bandwagon saying, see, guys, the asymmetries don't matter. Look at the fastest man in the world is asymmetrical. And I'm like, well, wait a minute, aren't you just the guy that was ripping us on leg length discrepancies aren't realistic? And it's just like, do you have nothing better to do than to just look for holes in people's theories? And but anyways, that was a bit of a pet peeve. But last week we put up something on, it was last podcast, excuse me. We were talking about Usain Bolt and that whole New York Times article. That was podcast 128, I believe. This is 131, I think. But let's talk about leg lengths and asymmetries and center of posture and these things. I still think these things do matter, and I don't care if there's a debate because I'm willing to be wrong and to learn from being wrong. I don't have to be right, but I guess I need enough of a shot in the arm to say, hey, pay attention, you're really off the mark here, for me to jump ship and jump into the asymmetries don't matter, because I still think that they do. I wrote down a couple things here just so I wouldn't miss them, but let's see. I mean, in this article, this is the article that did allude to some vision stuff, right? Is this the one where I had the clients close the eyes? I think they did at some point. Maybe it was the following study.
No, it's the other article that was talking about closing the eyes, not this particular one. Yeah. This one basically just showed people with LLDs change their center of pressure. Mm-hmm. And, that kind of makes sense, but this is an article that actually showed that. So what they're saying is that weight bearing changes when you have an anatomical discrepancy from side to side. And
but they also said that there was no significant differences in posturography between the groups that might indicate compensations. And that just told me that they adapted to the center of pressure alteration, right? Well,
but static posturography is just like you're looking at looking at them. It's not like we're looking at a measurable, I guess you're looking at a measurable parameter to some degree, but it's not like center pressure is center pressure. I mean, it either changes or it doesn't change. There's not I think his right hip is high or his left shoulder is low or whatever. So what they were saying is, one, posturgraphically there wasn't a lot of change, but two, COPs changed. And in the conclusions, they basically said that sight was important in postural control, but more importantly, center of pressure sway velocities suggest a proportional deterioration of postural control with increased value of leg length asymmetry. So in other words, the bigger the difference, the more the COP change. So if you change weight bearing through a structure, it's going to alter things like pronation. It's going to alter things like supination. It's going to alter the vestibular system. It's going to alter all of these other things. And I'm sorry, these people did do a tandem stance, eyes open, eyes closed, but it was also talked about in the other article as well. But anyway, that was kind of the gist of the article, and it just sort of like, well, all right, that makes a lot of sense,
I mean, think about Usain Bolt. We'll just use him as an example because everybody thought that, there was a rant for quite a while until he got injured and lost 2 races in a row that, asymmetry doesn't matter. He's still the fastest man in the world. And, well, he just got injured and he lost 2 races, so maybe it does matter. I'm just taking that pat on the back again because a lot of people ripped on us pretty hard. But, I mean, think about it. The brain's fighting to find the horizon, right? It's fighting to get the eyes on the horizon. It's trying to get the vestibular system, the ears on the horizon. And so if you've got 2 legs that are different lengths and you're trying to find the center of pressure on there, there's going to be some postural drifting. And I'm sorry, man, but if you've got this distorted center of pressure and you're spending some of your time and resources recalculating center of pressure and equilibrium and balance, I'm pretty sure you're not using those resources for performance of that client, And so I still think asymmetry does matter. That's taxing the resources of that system to some degree. Sure, it might be small, but if you didn't have to do that, and if Usain didn't have to do that, it's quite possible he could run faster. I mean, you've got 2 legs, and if they're both, XYZ length, symmetrical, you've got the pelvis that's level. You don't have to, and then you've got this single column spine that comes off of this balanced pelvis. The system doesn't have to work as hard as a system that's got a short leg. The pelvis is unlevel. Now you're going to have some more frontal plate frontal plane drifting. You're going to have some pelvic distortion. And then you're going to have the system of the spine on right and left sides fighting between increased tone and tightness to try and maintain stability, because the base of this thing is no longer square. Don't tell me that client isn't eating up resources posturally to make the system work. Now, I don't dismiss the fact that over time they're going to compensate, but that compensation has a cost. I'm sure you can ingrain a really bad pattern and get really good at it, but don't tell me that system might not have the same performance or economy or efficiency as a system that didn't have to deal with that and just focused on moving sagittally through the plane, through the forward plane as a sprinter. So I just really, I don't know. I have not heard or read enough that tells me that asymmetry doesn't matter yet. And I know that you feel the same way, right?
Mm-hmm.
I just think that was the worst example, and everybody jumped on that bandwagon. And one guy said, "Hey guys, don't worry about it." That newspaper isn't exactly the most reputable to begin with, but it was just funny how everybody has jumped right on that. And since then, I know that you guys, and I've promised this, and I will get to it. My brothers at Harvard did get me that full article, and so I have it. And as I've said, it doesn't quite say what everybody thought it said. So. That will be interesting. But, you and I do like these leg length discrepancies, structural or functional. It does have an effect on center of pressure and how you maintain vision and balance and symmetry and arm swing and leg swing. I've got this article on arm swing that I'm putting up at some point here. And the drummer for Def Leppard, I'm trying to remember what his name is. Phil, is it Phil Allen?
Phil Collin is the guitarist.
No, I think it's Phil Allen, because I think he had the same last name as me. But anyways, he lost his arm in a tragic accident, and then they figured out how to get him to drum again, and using pedals and whatnot. And he remarked that as soon as the doctors let him get out of bed, he practically fell over. He didn't know how to stand up because he didn't have that arm as that equilibrium balancing ballast type system. So, here's a guy who really wasn't walking, but he couldn't even walk around his room post-operatively within several days of having that amputation. So don't tell me the system doesn't, don't tell me asymmetry doesn't matter. I mean, can he walk now? Yes. Why? Because he's learned to adapt to it. But don't tell me there's not a cost to someone who doesn't have an arm. We're not talking about that with Usain Bolt, but we're talking with somebody who has some significant differences that are taxing the system and his resources to perform. So maybe he should come out of retirement, but first he should go out there in Colorado to see Ivo.
Yeah, I don't know about that.
We could make him faster. We'd never have to ever look for a patient again. Not that we do, but I didn't get to the second study on this, did you?
The one on joint movement asymmetry in healthy populations?
Yeah.
Basically they said that healthy people move asymmetrically. That was the gist of the study, and that was part of what came up a few weeks ago, causing that storm about all these clinicians that are looking at asymmetries, in people. That really doesn't mean anything. No, it doesn't mean that. But they didn't do a study on people that had pain that had asymmetrical. They looked at asymptomatic individuals.
Yeah.
So, they found a high amount of asymmetry between the limbs in healthy populations, and this was greater than a 10% variability from side to side, which is pretty big. And it just goes to show you that asymmetry kind of is the rule. But it's the larger degree of asymmetry that we're looking at as far as what's going on, and is it symptomatic or not?
Yeah, or as we proposed in our pieces this week, what if someone has a low degree of asymmetry, but they now fatigue? Are they going to fatigue faster? And does that asymmetry become more cumbersome as they fatigue because they don't spend enough time way out there on the end of their endurance or fatigable challenges, so they become even more malcoordinated as that asymmetry becomes less controllable, as opposed to someone who is perfectly symmetrical, although they probably don't exist, but let's say they did. As they fatigued, at least they'd be fatiguing in symmetry, at least if they fatigued everything symmetrically. But, I mean, we're getting down a rabbit hole here, but someone who has a leg length discrepancy and fatigues is going to have a different compensation and fatigue response to coordination and motor patterning than someone who is symmetrical. So it's a bit of a rabbit hole here, but I don't think that this is a debate that can be answered or will go away, because until we can clone people, as we alluded to in the last podcast, it's not possible to have, this completely, unblemished study. So, but anyways, that brought everything full circle there to endurance. That's for sure.
Yes, you did. No, and it's good. And we'll just mention that this one will be in the notes, guys, but it is a free full text. It's out of Gait Posture. It was from September of 14, and that'll be in there for you. You can read through it and, draw your own conclusions. That's what we always encourage folks to do is, don't take our word for it. Go ahead and read and decide for yourself as far as what's going on.
Mm-hmm. So take us down a little bit of a foot intrinsic rabbit hole here, since that's the one you put up.
Well, this is just a paper out of Journal of Physical Therapy Science. The study was just published in 2017. And the thing that caught me, because I'm always looking online, is does weakening of the intrinsic foot muscles cause decrease of the medial longitudinal arch height? So I was excited at the title. I was like, oh, this is going to be good. Mm-hmm. So the study, the basic part of the study, and there was a lot of flaws in the study. And basically at the end they say, no, it doesn't make a difference, which the conclusion didn't surprise me. But when you look at the methods, you're like, well, that really didn't show that at all. So what they did is they took the muscle that had the largest amount of cross-sectional area in the bottom of the foot, which is the abductor hallux. And then, because the abductor hallux, if you look at the anatomy, and you can go into our Tumblr archives and type in abductor hallux, and it will bring up a series of things that we've written through the years. But it is the largest, but what happens is it's more of a flexor than it is an abductor. Okay, and so their thought was, well, this is what's maintaining the medial longitudinal arch, so let's fatigue this muscle, and then let's measure the arch again and see, what's going on. And they don't use the standard navicular drop like most people. They use this. It's a 3D motion analysis system called the Oxford foot model, which is more accurate, and that has its own studies which show that. And basically what they did is they put the person in this plantar flexed posture of their foot and had them just flex the big toe basically against a wall, so an isometric contraction. And what they found is that after they did this, and you'll like this, the arch height actually increased, and they had less rear foot eversion. So theirs was what... Well, right. But you got to look at, first of all, the abductor hallux, yes, it might be a flexor, but how do you know what it is in this population? Two, how do you tease out, and they did mention this in the problems with the study, flexor hallux longus, function in here as well. So I really wasn't surprised, but I mean, what holds the arch up besides the actual interlocking of the bones? It's largely the anterior compartment. Yeah. And if we think about the arch needs to collapse from initial contact through mid-stance, that's what's supposed to happen. And then from mid-stance on to terminal stance pre-swing is when the arch is supposed to become more supinated. That's when the intrinsics are, going to be more active at that point when you look at the EMG studies. They also sort of said, oh, well, we're also going to get the flexor hallux brevis in there, because it's in there and it's in the same area that we're looking at. Anyway, the study was a little silly in that I don't think, if you're going to look at intrinsics, wouldn't have made sense to look at a different set of muscles. But then again, how are you going to pre-fatigue those? And determine that. You can't just do E-stim on them for a long period of time because that may actually facilitate them. But anyway, the title is what caught me, and we talked about that, and we pointed out some of the pitfalls. It's on the our the blog, as well as if you want to look back in social media, you can pull it up there as well.
Yeah, and people get really wrapped up in this intrinsic stuff, and these are my foot exercises to make my intrinsic stronger, and a lot of the times I try to hide my eye roll and my smirk, but it reminds me of a case that walked into my office last week, and it was a fellow practitioner in the area, and he came in, he says, God, I got to have you look at my toe, man. And it was at the end of the day, and I know I was done, and that's typically when I will agree to see someone else in the profession, because I don't generally charge those folks. And he came in, and he's got a slight hallux limitus, and it's painful. I mean, you bring him up into, maybe 45 degrees of hallux dorsiflexion, and he gets a loss of range, and there's pain right there. It's clear. And I said, how's your toe off? And he goes, oh, that's when it kills me. And I said, so do you have any pain on the bottom of your foot? And, he says no. And so I check out the sesamoids, and they're actually mildly tender. He was surprised by that. I wasn't. And I had him lay on the table, and I had him plantar flex both feet. And he couldn't fully plantar flex that foot on that side. And I said, looks like your calf might be a little weak. Let's assess this. And the calf was weak. And I said, okay, well, we can probably help you with this. And at this point of the day, I was a little slap happy, a little bit low on my blood sugar, and I got a little cocky, and I said, yeah, this should be pretty easy. And I went over and tested his tib posterior, and that was weak. And I said, so what do you do with this thing? He says, well, I mobilize the toe into extension. And I said, do you plantar flex the first ray, the first metatarsal, before you mobilize that in extension? And he said no. And so I showed him that when you actually dorsiflex the foot in the first ray and you try to extend the toe, it locks. And so I showed him that when it plantar flexes, you get more range. And I said, that's why you're having troubles at toe off and at 45 degrees. So I said, what if your calf was weak? And what if your tib posterior is weak? How well would you plantar flex that first metatarsal, let alone plantar flex your ankle? And he goes, well, there'd probably be a limitation. And I said, so would that affect that eccentric axis at the big toe? And he goes, I guess, and I realized I was kind of pushing a knowledge level there. And I said, look, if I can get you to plantar flex that first metatarsal and plantar flex the ankle a little bit better, do you think you'll get better clearance at the big toe and more dorsiflexion? He goes, sure, maybe. And so I had him stand up, and we did his good side first, and he got to about a minute and 15 seconds before the calf started to fatigue. And I said, I know you can't come up on your affected side and do a heel rise all the way because you're going to jam that toe. But let's go to as far as you can until you have pain. Then I want you to back away just a few degrees, and I want you to hold it. And he backed away, and at about 10-15 seconds, he started fatiguing. And I said, okay, hang out there for a little bit longer, or if you start to develop pain. We got to about 25 seconds, and the fatigue was kicking in. And I knew I wanted to do several sets. So I brought him back down, and I let him recover for 2 minutes, which we talked about in the Lost podcast. And I let him recover for 2 minutes, and we did it again. And he got another 5-10 seconds longer, came back down. And we did it again. And we did it 2 more times. And then I had him walk around the office, and he said, my toe pain is gone. I can toe off a lot better now. And I showed him on the table that he had a greater range. And so I showed him that just doing an isometric in the calf at the limit, just below pain, this is kind of Joe Cook's work, he was able to gain more stiffness in that position, facilitate more of the plantar flexors. The tib posterior was a little bit stronger, which means he was actually probably plantar flexing, even the pronatus longus was better too. So it means he was plantar flexing that first ray a little bit better, which means he was getting more clearance at the toe. And so I said, I want you to do this for a couple more days, and I want you to send me a text. And he did at the beginning of this week, and he said, I have no toe pain anymore. The range is still off, but I have full gait no toe pain, and I can come higher into my isometrics. And so it's just classic example of if you can't get into plantar flexion maybe at the ankle, it's probably going to affect plantar flexion of the first metatarsal, which is going to affect the joint after that, which happens to be the joint where everybody gets kind of, cremated in terms of their function. It just dies off. You start losing the range of dorsiflexion because you start losing your ability to plantar flex the first ray. And I think there's almost a 1-for-1 there, at least in my mind clinically. If you're losing plantar flexion of the ankle and of the first ray, you're probably starting to lose dorsiflexion of the hallux. You can't have both of them. If one peels back, the other's going to. So I'm starting to think, after I've been playing with this for a while, that functional hallux limitus may just be a component of calf weakness or fatigability. Be an interesting experiment. If you're not experimenting or playing around with that, let's do our kind of unofficial little experiment here. But have you had any experience with this? Have you played around with that? Does it make sense? Are there some holes in my theory?
It makes a lot of sense as far as what you're talking about. I'd have to say that I approach that a little differently, but I think the results are ultimately the same, and that's basically trying to get more plantar flexion of the distal aspect of the first ray. And I probably do that indirectly through training, pronatus longus function, extensor hallucis brevis, and hip extension. Mm-hmm. So I'm getting there, but I'm not specifically looking at the calf or the tib posterior, which until you just mention it now, it's like that makes a whole lot of sense, but I just hadn't been doing. I'm always looking at, the pronii and things like that. But we see a lot of that. And for those folks that they just can't do that, you can help them out a little bit by making a little bit of a first ray cutout in their sole of their shoe. So you cut out under that distal head of the first, just to allow it to drop down a little tiny bit, to give them that little extra bit of plantar flexion so they can get into the dorsiflexion. But emphasizing again to the person, like, look, this is a crutch. This is not fixing the problem. What it's doing is giving you a range of motion so that we can exercise you more into that range. But I like that. I'd have to say, and maybe I just don't check it enough, I just don't see a ton of gastroc weakness in my practice. I see lots of people with tib posterior stuff, but not necessarily gastroc. So
yeah, and I didn't either until I started looking a little more carefully. And there's a lot of people that have really good gastroc, posterior compartment strength up until about 80% of their what I call top end range. But you ask them to come all the way up, and I have them usually stand in front of the physical therapy table, and I have them plantar flex. I said, get onto the ball of your heel or the ball of your foot as high as you can raise that heel up. And then I say, take your hands away. And they usually say at that point, I can't hold that top end. And they will literally drop down to about a 75-80% height. Whereas on their non-affected side, they feel, I feel more comfortable at that top end. But I do think there's a fatigability issue here. And I think it's a lot of the case in runners. As you lose a little bit of that calf, strength, you lose a little bit of that plantar flexion, which means you're losing a little bit of hip extension. And now the glute's feeding down. Now you've got that whole Z angle thing we talk about starting to erode away. But I encourage folks who are listening to this, if you've got some toe pain or functional hallux limitus pain, or even a little bit of true hallux rigidus pain, go up into your calf raise. Make sure you're loading over the medial compartment, not over your lesser metatarsals. Make sure you're not in pain, and hang out there and build yourself up to about 2 minutes. I'm not telling you to do this as your doctor. I'm saying experiment, okay? And do that several hours for, build up to 2 minutes, but you want to do it every single hour or as often as you can over the next, say, 5 to 7 days. And you should be able to gain some more stiffness in the posterior compartment, a little bit of more strength. And what you may notice is that your plantar flexion range becomes a little bit more robust, and maybe you can hold it a little longer, maybe you can come up a little higher. But in essence, if you can get that first metatarsal to drop and get that whole metatarsal first met and ray complex to plantar flex a little bit more, you're probably going to get some reciprocal changes in the dorsiflexion range. It may take some adaptable time for that capsule to become less inflamed and for that joint to be encouraged to come a little further, to get the sesamoids to slide back a little bit, but you may be quite surprised. I did it on a friend of mine who I do jiu-jitsu with. I saw him Monday for this very same problem, and I saw him in jiu-jitsu today on Friday, and he said toe pain is significantly better. He says it's amazing, and I said no, it's just science.
Yeah. So. Well, here's something to wrap your head around. Because as you're talking there, I'm thinking. So most people are flexor dominant, as we know, right? So if you're calf flexor dominant, I wonder, and we'd have to do muscle biopsies to see this, do you have a tire proportion of type 2 rather than type 1 muscle? So they're plenty strong when you test them, but the point is they don't have the endurance. You know what I mean?
Right.
And are we looking, and I'm going to have to look now because now you've piqued my curiosity. I'm going to have to go, like, after we're done, I got to pick my kids up, but then I will do a quick PubMed search to see if there's anything looking at fiber type percentages in calves. And then if that's the case, then we can kind of revisit that a little bit. But that would be really interesting, an interesting thing to look at and an interesting theory, just as far as the whole skill, endurance, strength. I always think of, everybody's super gastroc dominant, but maybe they're super gastroc dominant from a strength perspective, but not from an endurance perspective. So, and I'm always working endurance in the anterior compartment,
Me too. This is a big shift for me. And I started finding this when I started looking at Joe Cook's work on Achilles tendinopathy and trying to help my Achilles clients. And then I realized that a couple of them had said, hey, I'm doing a lot better. Did you mean for my big toe pain to go away? Because that's better too. I'm like, oh, well, of course I did.
Of course, yes.
I realized, oh, wait a minute, they're plantar flexing better, and we know that joint is an eccentric axis at that big toe. And the more you can plantar flex that first metatarsal head, the more that eccentric axis shifts, the more dorsiflexion they get just passively. So it has to happen and correlate actively too. And I started realizing, oh, wait a minute, they might not have top end strength, and they might have an endurance problem. So most people are pretty good mid-range. There's good performance there, pretty good endurance, but you ask them to go to the top end and things change. So
yeah,
and that kind of comes full circle into the hopping drills that we talked about on the last podcast, or 128. We talked about hopping and performance rehab of making sure your clients have equal hopping skills, distance, ability, etc. And certainly if the calf isn't performing, your clients are going to show up in that hopping drill. So once again, hopping drill comes full circle here.
All right, man, we are well over an hour here. We need to wrap.
Yeah, let's cut it. Let's shut it down. I'm Sean Allen in Chicago.
I have a whirl up in Dillon, Colorado. Thanks for listening.